This is Tim O'Brien from Seattle on October 31st, 2025. Happy Halloween, and now for today's news. First, a security story. NPM is flooded with malicious packages downloaded more than 86,000 times. And this is a story by Dan Goodin from Ars Technica. Security researchers discovered a flood of malicious packages on NPM that can fetch dependencies from untrusted sites. These packages were downloaded over 86,000 times before being detected and removed. The packages use dependency confusion attacks to trick developers into installing malicious code instead of legitimate libraries. These attacks highlight how supply chain vulnerabilities can affect millions of developers and users. When your package manager can't be trusted, the entire development ecosystem becomes vulnerable. The technical details here are fascinating and scary. Security firm COI discovered this attack campaign, which they've dubbed Phantom Raven. The attackers used a technique called slop squatting, registering package names that look almost identical to legitimate names, but with subtle differences. These rogue packages employed remote dynamic dependencies, or RDDs. This is a technique where a package's package.json file points to a dependency via an external HTTP URL instead of a version number. And here's the brilliant and terrifying part. They specifically targeted AI-generated package suggestions. So when AI assistants like ChatGPT or Cursor or Copilot hallucinate and suggest plausible-sounding but non-existent package names like unused-imports instead of the real ESLint-plugin-unused-imports, developers trust the AI and install the malicious package. It's a perfect storm where our increasing reliance on AI tooling becomes the attack vector itself. Do read this Ars Technica story by Dan Goodin, but also go over to the COI description of the vulnerability itself. Also, similar to Shai Hulud, this particular attack is targeting developer workstations and looking for credentials related to CI/CD. The next news story this morning is a blog post by Dr. Emily L. Hunt, who appears to be an astrophysicist. She has a blog at emily.space. It's about UV, which is a Rust-based Python package manager and environment tool from Astral, the makers of Rough. It can install Python versions, manage virtual environments, and resolve dependencies extremely quickly. It claims to be shockingly fast and works consistently across operating systems. But the main pain point this solves is that Python developers have to cobble together so many tools and they don't always play well together. Pip, virtualenv, conda, Poetry, PDM, pipenv, and if UV delivers on its promises, it could finally unify Python tooling into something as streamlined as what other languages enjoy. The speed claims are dramatic. They say it's orders of magnitude faster than traditional Python tooling, thanks to being written in Rust. What's particularly interesting here is that UV represents a broader trend in programming language tooling, using Rust to build faster tools for higher-level languages. Just like SWC, Speedy Web Compiler, rewrote JavaScript and TypeScript compilation in Rust to be 10 to 20 times faster than Babel, UVA is doing the same thing for Python package management. If you want more information about UV, please see links to Emily Hunt's blog post and the UV project in the show's notes. For today's Weird Bucket story, it's numerical. The title of the story is 987654321 divided by 123456789. John D. Cook wrote a blog post on johndcook.com about how this fraction, again, 987654321 divided by 123456789 equals exactly 8.0000000073. That near integer result is not a mathematical accident. It's connected to the decimal expansion properties. He writes all about this isn't just something you see in base 10. It also happens in other bases. So if you're interested in math, it's very interesting. Sometimes math surprises us with elegant patterns that are hiding in plain sight. Today's focus is going to be me talking about some of the posts that David Heinemeier Hansen has written about moving Basecamp and HEY from public cloud to private. In his posts, he talks about real savings, real success. And today I'm going to talk about why I respect his position, why it worked for them, and, this is the important part, what everyone else needs to think about before they copy and paste this playbook. Because while his math is solid, there's a lot more to this calculation than hardware versus EC2 pricing. So before I get into that, I just want to talk about something that's important. Let's talk about some context with David, DHH. I've interviewed him in Chicago years ago. I interviewed both David and Jason Fried, Jason at the 37 Signals office in the West Loop and David in Wicker Park. If you search, you can probably still find those interviews on YouTube under the O'Reilly account if you want to see me with really awful hair in 2008. But here's the fun story about that interview. At the end of the interview with David, we literally ended up running from the cops. Someone from the Chicago Parks walked up, interrupted us, and asked if I had had a filming permit with me. I said no, and he said, "Oh, I'll be right back. I'm going to call the police." At that point, David and I looked at each other, started walking, and before you know it, we're sprinting down the street, me with a large camera, next to the creator of Rails. Now that's a fun story. I'll bet he remembers it. It's not often people run from the cops. But I think he also remembers a fairly awful interview. It was one of my first. But I'm uniquely qualified to respond to DHH because he and I have both fled law enforcement together. And you're going to be surprised I'm defending his success. He's known for being combative in tech debates, but I respect people who have strong opinions and defend them relentlessly. He shows up with a clear position, argues for it forcefully, and backs it up with evidence. He's a fighter who doesn't give up. I mean, he races under the Danish flag in the 24-hour Le Mans race. That has to be respected. And on this particular topic, moving from public to private cloud, DHH has picked a fight worth having. His position is 100% valid. There are absolutely workloads where owning your own infrastructure makes economic sense. 2 years ago, he wrote that public cloud was too expensive for their steady workloads, and he's since shown big savings moving to owned hardware in a colo. For their shape of business, mature apps, predictable loads, strong ops talent, that choice has paid off. But now I'm going to dive into some of the complications, because a lot of people read his posts and they think, oh, let's do the same thing. There are some things I want you to think about before you do that, because it's more complicated than that. So let me tell you something I have learned from moving workloads between public and private cloud. That public cloud bill that feels like a punishment, it's actually a feature and you need to take advantage of it. When you move from private to public cloud, that first invoice feels like a punch in the face. It wakes you up. Cost becomes a live, daily signal that forces immediate architecture decisions. Suddenly you're asking hard questions. Why are we storing 3 years of debug logs? Why is this dev environment running 24/7? Why does this cron job hit the database 10,000 times a day? Why do we have 12 copies of the same service running in different regions that no one uses? The bill forces you to delete stale data, right-size instances, slow down noisy processes, and consolidate duplicative systems. It's like a daily cold shower that keeps you honest about waste. When you move to on-prem, that pressure evaporates. Infrastructure spend becomes sunk CapEx. It feels free until the next hardware refresh cycle. The discipline fades, waste accumulates quietly because there's no monthly reckoning. And here's what's not being told in a lot of these "we move to private cloud" stories. When you lose track of efficiency in private, you don't run out of money first. You run out of capacity. You start to run out of space. And when that happens, you can't just spin up new instances. There's no procurement that's immediate. There's supply chain issues to figure out. There's racking and stacking. It's not quick. The lesson here is that the cloud bill isn't the problem. It's a diagnostic tool. But if you're going to private, don't throw away that tool. You need to continue to measure some cost model that gives you a daily rate. And you need to pay attention to it as much as you would have were you on public cloud. You need to replicate that cost signal internally through showback, chargeback, and rigorous capacity reviews. And that's something you can get. There's a number of vendors that sell tools that allow you to create cost models that replicate exactly what you would have had on public. So again, I just want to warn you, if you do move back to private cloud, you need to have a way to capture the cost. And for the record, most people don't do that. When they move something back to private cloud, they're really just starting to think about CapEx. Don't make that mistake. Even if your cost model is fiction, it's still going to be valuable to drive the right actions. When you're on public cloud, the one thing you have is an incentive, that bill, and you want to minimize it. Try to take the same approach on private cloud. The other important thing to think about after you read David's posts, there's different workloads. Let me be specific about when private cloud makes sense. If your workload is static, if it runs 24/7, 365 with no meaningful scale up or scale down, and if you're not using any platform as a service features, you're really just running VMs you manage yourself. In that case, there's not much point paying the tax for public cloud. I've got a couple more reasons at the end of this post to think about, but if you think you can handle it and run it on your own infrastructure, you can absolutely achieve savings. But there are services where you're not going to beat public cloud. Storage is one of them. I don't think you're going to ever achieve the same level of scale or efficiency for storage that you'll get from an S3 or a Google Cloud Storage. Sure, someone will say, I have a Ceph cluster and it costs 1/3 as much. Maybe. But storage isn't just cost per terabyte or petabyte. It's backups. It's intelligent tiering, moving data between hot, cold, and archive levels automatically. Yesterday, Neem Patel posted about their repatriation and made the same point. At the end of his post, he said they still use public cloud for storage because they couldn't find a solution that was cheaper when you factor in all of the operational overhead. GPUs and novel SKUs are another area where the calculus can get complicated. If you're a large organization and you want to run GPUs locally, it can make sense at times. But the level of CapEx required is enormous, and the real limiting factor is expertise. Building clusters of GPUs requires people who know how to deal with heating issues, with cooling issues, people that know how to configure network routers so that they won't melt. The other place where private cloud isn't optimal is for workloads with variable demand. If you have a workload that needs 8x your current capacity for 3 or 4 days a year, you'll likely want to exploit elastic public cloud, or you might want to use a hybrid approach. But if you do use a hybrid approach, the other thing you need to really calculate is ingress and egress. It's important that you do the math before you make a decision like this. And it's important that you look at your workload and understand if it's similar to DHH's workloads. Again, Basecamp and HEY at 37 signals are workloads that seem to be relatively static. They're going to run all year. Again, and I want to emphasize, I'm not saying don't do what David did. I'm just bringing up some things for you to think about. The next thing is security and operations. I have been responsible for operating a MySQL database in production at a very large scale. This was for Scholastic years and years ago. And I have to tell you, I still have PTSD from the experience. There's things you learn about relational databases that you don't know until they're under heavy simultaneous load. I wouldn't want to do it again. If I'm going to run a database, I actually want to run towards something like Cloud SQL or RDS or Azure SQL, because I never, ever want to have to think about I/O or hard drives. I really just want to click and forget. Easy is not the word I would use. Someone in the comments of David's post on LinkedIn said, we run MySQL ourselves. It's easy once it's set up. Again, disks fail, replication drifts, backups rot, schema migrations land at 2 a.m. Hardware does not apologize. But more concerning is security, because this is where the conversation gets really serious. When you use Azure, Google Cloud, or AWS, there are thousands of people working at those providers that are doing quiet things that you'll never see. Microcode and firmware updates, live migrating of VMs off of suspicious hosts, hardware attestation, KMS durability guarantees, background scrubbing, cross-region controls, compliance audits. And when bad things happen, they also have security teams that wake up and figure it out. Now, can you do all of that yourself? With the right people and process? Yes. You have to hire the right people, though. So it brings it back to the same challenge with GPUs. You can install your own GPUs, but you're going to have a couple of Oppenheimers on your staff. That team costs real money. The security team, incident response, vulnerability management, red-blue exercises, forensics, rotating secrets, tabletop disaster recovery exercises, third-party audits. And then there's physical security. Vulnerabilities like Tfail that I talked about yesterday. Somebody gets access to your compute. All they have to do in 3 minutes is drop a $1,000 attachment between your memory and your motherboard, and they're in. They've got everything. So when you work with a hyperscaler like Google or Microsoft or Amazon, you're working with a company that has an information security team of thousands of people involved with a much larger community of experts, people who understand the full attack surface, from physical security to side channel attacks to supply chain risks. Now, if you have that team, that's great. Take advantage of the colo, move to your own infrastructure. And some companies have that. But if you don't have that, you're on your own for some of the most complicated security issues that you've ever even thought about. And it's happening every day. And your customers' data is out there as well. Just go Google Red Team Operations Stories, and you can see that there's a couple of podcasts out there that talk about some of more creative red teams getting physical access to data centers, badge cloning, social engineering. These aren't theoretical threats. They're documented operations. So if you are going to run your own infrastructure on your own hardware, what I hope is that you don't face a well-funded adversary. I'd encourage you to find a third party to try to get around your security, run a real penetration test, do red team exercises, because the hyperscalers have hundreds, thousands of people on staff thinking about this every single day, and it's getting much more complicated every single week. The last thing I want people to think about, again, I just want to reiterate, I'm not saying like DHH is wrong, wrong. I'm not trying to start a fight. I'm just saying these are things you need to think about if you're going to move back to private cloud. So let me tell you a personal story. In 1997 and 1998, I dropped out of college for about a semester, maybe a year. I had a business building a search engine in one of the oldest buildings near downtown Charlottesville. We had a lightning strike on the building. We actually had a backup, but the lightning strike took out both the backup and our main computer. This was before cloud. We really didn't have a good strategy for recovery. I ended up going back to school and finishing my degree. So you could say that lightning was the reason I went back to school. But since that time, in every role I've ever had, there have been those events that happen that are just unpredictable. Multiple disk drives failing at the same time in ways that you can't really explain. Multiple power outages in states that you don't expect them to happen in the winter. Backhoes cutting fiber optic lines in places you had never even heard of. There's also cases where you can get hardware that doesn't work. A rack that bends because the metal is too weak. That's an OSHA violation. There's also physical security, which you really don't have to manage. Man cages might sound interesting, but they're not. These are things which, through experience, I would love to delegate to a hyperscaler. But there are also black swan events, international pandemics, crises that you can't predict. And I'd rather be using a company that has 100 data centers and a staff of thousands to manage them, rather than saying, well, we put our data center in a city that's going to be offline for a couple of days. The other event I like to talk about a lot is Chelyabinsk. Chelyabinsk is a city in Russia, and in February 2013, a meteor exploded at a high altitude and created a shock wave that caused widespread damage. You can see videos of it online. Power outages, thousands of broken windows, injuries. I think technically it was a meteor that was called a bolide, and it exploded at 30 kilometers up in the air. And the reason I bring that up is because that's the kind of thing where if that had happened over Herndon or Reston, it would have had an impact on a lot of different data centers. If that had happened over San Jose, we would have been talking about an outage or multiple outages. These things are unpredictable. And if you're watching the news is getting more unpredictable. So if anyone's like, okay, I can do it better than Google and Microsoft and Amazon and Oracle, I'm going to move it into my own private data centers, that's great. But you're also making a bet that you can manage the unpredictable at your scale, at the scale of one. That is the biggest concern I have when I hear companies saying, oh, let's just go back to private. It's easy. There are times when bad things happen, and it's great to be able to pick up the phone and know that there's a company with millions of cores, tens of millions of cores, billions of cores even, that's able to help. The last thing I'll say, and again, I don't want you to view this as a response. It's more think about these things before you just say, yeah, we're going to do this too. Before you buy pallets of servers and tell everybody you're going to move back to private, I need you to do the grown-up FinOps work in the cloud. Look at committed use discounts. Look at reserved instances. Look at savings plans. Right-size your SKUs. Turn off zombies. Model effective cloud rates, not the list prices. Then compare to all-in private costs. Have complicated conversations about amortization. Are you going to amortize your GPUs over 2 or 3 years? What about other hardware? Is it 5 years? Get the cost of colo space. Get the cost of power, which will be unpredictable going forward. Get the cost of bandwidth. Model hardware failures and spares. If you need cyber insurance, model the cost of that. Model the cost of security and compliance, disaster recovery, worst case costs, multi-region design, and most important, don't just think you can do it without hiring anybody. There's going to be a point at which you need to hire someone who is dedicated and able to jump up at any moment and do unpredictable things with hardware. Again, I'm not telling you not to do this. I think DHH savings are real, and I have a lot of respect for 37 Signals. Frankly, they could have gone so many directions, but I see them and they're still where they were. I think they still have the same office that I visited back in like 2008 or 2010. They're in the West Loop. They're in Chicago. They have a sustainable business. But I also think that David and Jason are in a really unique position. They have some of the smartest people in the world working for them. They're also extreme perfectionists, and that applies to their hiring. The other thing to consider is the level of output he gets from that team. David is the inventor of Rails, a framework that inspired an entire industry. I used it for several years. He's created his own container management framework called Kamal, his own Linux distribution. So I'm not particularly surprised that public cloud doesn't line up with his perfect vision of how he wants to run software. And frankly, if you look at what they're doing, they're running their own platforms. And this is what they do well. So he has the people that can get this done. If you read his post and think, oh, I can save money on private cloud, I want you to think about what you're doing. Do you have the same level of talent? I also want you to know that his company is at a sweet spot. They make money and they make enough money for this to be a reality. If you use less public cloud, it might not make economic sense for you to move to private. If you use more, it might make sense. But I think the most important thing I want you to understand about this is that you need to do that math. You really need to look at the whole picture. You need to look at what are your teams doing? Do you have a lot of dynamic requests? Does the volume of usage change over time? Do you have projects that are proof of concepts that might go away? Do you have projects that you can bet on for 10 years? This is the sort of thing you need to do. And I would recommend that if you're thinking about moving either to public or to private or to a hybrid, that you model each workload in its complexity. So the future here isn't dogma. The future here isn't, well, private's cheaper, so move to it, or public's more agile, so move to that. I think the future for most of these companies is steady base loads can be on owned gear, but keep the bursty experimental workloads and the AI workloads on cloud. Preserve cloud's cost signal through showback or chargeback so that on-premise stays lean, and revisit the decision yearly. I see a lot of what the hyperscalers are doing right now. And what I have to tell you is the whole notion of compute is being transformed by the pressure that generative AI is putting on data centers. The way that we run compute is going to change in a fantastic way over the course of the next 5 years, in ways that I'm not even going to predict. So what was right in 2022 and 2025 might not be right in 2026 or 2027. Don't take this as me saying, no, David's wrong. This is me saying it's more complicated than that, which is probably the thing I should put on my shirt. But if you read that post and you retweet it and you upvote it, that's great. I upvoted it as well. But I'm writing this piece so that people understand, just like the utilization story I wrote yesterday, it's complicated. It's awesome, but it's also very complicated. If you've repatriated applications, which I'm not sure I'm happy about the term repatriated, I like to say migrated. If you've done this, and you've experienced it yourself, I would love to hear about positives and negatives. You can contact me on LinkedIn. I didn't weigh in on David's post 2 years ago, but I am now. It would be good for us to compare notes. And I think the other thing I want to say is that David is an important voice. In this case, I think he's correct for his situation, but I don't know if his situation is the same as everyone voting it up. Now, I'll just leave with one more thing. It's just something I have to say. A lot of the people clicking like on his post are also motivated to do so because of what they do. I noticed a lot of hardware manufacturers really love this story. And I just want you, when you read these stories, to think about that. There's always interest at play. So if you want to learn more about this, I have a lot of links in the show notes. I think it's important that you go read David's post. It's important. He is an important voice to listen to. But I also think it's important that you understand the Chelyabinsk meteor event, because that's cool. And you'll only hear about weird stuff like that on this podcast. So thank you for listening. And I'm going to go because I have to move a bunch of workloads back to private because it's like 40 times cheaper. Thank you and have a good day.